Hello YouTube viewers, welcome back to my channel. I'm Sri Tips, and today what I have is about a pound of jeweler's bobbing compound. And what this is a wax-based material that contains an abrasive grit that's used to shape pieces of jewelry. Unlike buffing compound, which has a very fine grit in it, the bobbing compound has a very coarse grit that is used to take lots of material away on the buffing wheel that we use. And I'll talk a little bit about that and show some pictures of the difference between the buffing wheel and the bobbing wheel. They're both buffing wheels, but one's used for bobbing compound, the other is used for buffing compound. So what we're going to do is process this and get the precious metals out of this in this video. Before I go any further, I'd like to take the time to say thank you again to all those who have contributed to my PayPal account. That's very helpful, and I really appreciate those donations. So, okay, without any further delay, let's get right to it. Jeweler's bobbing compound. This is the jeweler's buffing wheel that's used. We use bobbing compound on it. That's this material right here. It has a very coarse grit that will shape the ring rather than polish it. And if you leave that on there too long, it'll take the material, it'll eat right through the ring. And this is the material we'll be refining in this video. Okay, by contrast, we have a buffing wheel where we use some fine grit material to put on this wheel. And then we take the ring or whatever jewelry item we're working with. You can see it's got a dull finish on it there. And we use this buffing wheel. It's got a very fine grit on it to buff all the scratches out and put a bright, shiny surface on the metal. First thing I want to do here to get started is get the weight of the bobbing compound here. We've got 461.4 grams. Take off about 5 grams for the bag, and that'd be about 456.4. About 1 pound of jeweler's bobbing compound. The time right now is 4:15 p.m. What I've got here is a coiningware dish on an electric hot plate. I'm going to turn the heat all the way up, high as it'll go. And I'm just going to set the bag right in there and incinerate the bag and the bobbing compound together. It's been on the heat now for about 5 minutes. As you can see, I'm starting to get some smoke off of the combustible materials in there. The idea here is to burn off any material that will burn, so we end up with a fine ash. And just like to point out also, I'm working in a fume hood here, so those vapors and that smoke is being drawn away from me. It's been on the heat now for about 25 minutes. I use a glass rod here to start stirring some of the material up. Remember, this is wax. It's a wax-based material. I'm going to try igniting this now with a torch. Got the lid here, so in case the flames get too big, I can put the flames out by putting the lid on. Maybe this will help burn it off a little quicker. It's only been burning now for about 1.5 minutes, but I don't want that pan to overheat and shatter. They're pretty tough, but they're not bulletproof, and they will break if you get them too hot, so I'm going to extinguish the flames now. And we'll just let this go ahead and keep cooking like this. like mud. It's all wax. The time is about 8 p.m. right now, and still got a ways to go on this, but you can see that the material, the wax, is being burned away. And I think what I'm going to do here is knock off for the evening. I'm going to get me something to eat, get the sack early, and come back out tomorrow morning and finish this incineration process. It's the following morning, and I'm going to restart the incineration here of the bobbing compound. I'm just going to put this on high heat and continue to heat this. I got to get this to a fine ash, and right now, as you can see, it's still just a blob of wax with the abrasive and the gold particles embedded in it. So I'll need to go ahead and get that completely incinerated and burnt to an ash before I can proceed. In the meantime, what I've done here is I've set up some of my silver solutions here. These are 4 jars of this silver bearing solution from my gold refining operations. If you've ever watched me refine gold, the first step in refining is to take and inquart the gold with silver, and then I use hot nitric acid to dissolve the silver and the base metals out. All of that comes out, and I save these silver solutions. These are from my $27,000 gold bars refining and other gold refining that I've done recently. And then back here, let's see if I can get the camera set up for you right here. Back here, what I have is, this is some of the raw solutions, like this up here, that I've taken and added more sterling silver to it. Because these solutions down here, down in the front, are going to have lots of excess nitric acid, lots of free nitric acid in those solutions. And I want to use that up before I extract the silver. So what I do is I add sterling silver to the solution, and then normally I let it heat. Here I'm just letting it set, but I normally heat it up and then dissolve the rest of the silver until I got a little bit of silver left down here undissolved and no more fumes being produced. That's how I can tell that all the nitric acid has been consumed. I don't want to throw the nitric acid away. It's expensive and I want to use it, so I put additional silver in here. Once all that process is done and I know the silver has been, or the nitric has been consumed, I filter it into a filter flask like this and save it, and then I pour it into a clean beaker. And what we've got in here is bits of copper. See that copper? And what happens is, in accordance with the reactivity series of metals, the copper, being more reactive than silver, will cement out onto that copper, forming the familiar gray cement silver down at the bottom of the beaker here. It's called cement silver because the gray powder resembles wet cement. And I'll do this with this solution and back down the line until I have all these solutions processed and I get every bit of the silver that I put in back out, plus I get any silver and other base metals, possibly some platinum group metals from the carrot scrap that I processed. I get all that silver back. Here it is right here. Over here I've got a jar with some gold-filled scrap that I processed. Those solutions will have silver as well. So I just threw a piece of copper in here. You can see there's some silver cementing out. That's from my gold-filled scrap. I get all the silver and the platinum group metals back out of these solutions by adding pieces of copper to them. There's the copper. So a lot of people were asking about the silver. What happens to the silver once I get done with the gold refining operations? This is what I do. I filter, I consume the excess nitric, filter it, put it in a beaker, add copper, and I get all my silver back. The bobbing compound has been on burning now for about 10 minutes. You can see it's smoking nicely. As another side experiment here, someone had asked, how do we separate the gold from a silver plated necklace? And I've done just that in this beaker here. What I did is I just put the gold necklace in some dilute nitric acid, and as you can see, all it's left is the little gold foils from the gold plated necklace that was in there. This was silver as a base metal with gold over the top of it. And all I got to do now is just filter these little gold foils out, and I can save those and throw them in with my next batch of carrot scrap if I so choose. But I just wanted to show you that's how we get the silver out and separate it from the gold in some gold plated material. If you look down in there, you'll see that there's some silver nitrate crystals forming. So it's such a concentrated solution of silver nitrate that the crystals started crashing out of the solution down in the bottom of the beaker there. But if you ever wonder how to get the gold material from a silver plated or a gold plated necklace, that's how I did it. I just do it in some hot dilute nitric acid and dissolve the silver out, and the gold foils get left behind. Only took a few minutes, by the way. It's been on about a half an hour since I restarted the heat this morning, and it's looking pretty good here. The material is starting to turn into an ash. It's finally burning away like I want to see here. I just keep coming out, hitting it with the flame, and stirring it, and slowly but surely incinerating into an ash like I want to see. In fact, if you look at the bottom, you can see it's turning into a powder down there on the bottom as I scrape it off with this glass rod. And this is starting to look pretty good. Still got a ways to go, but we're making progress and headed in the right direction here. It's been an hour since I put this, reheated it, restarted it. And as long as there's smoke coming off of there, it means I've got combustible material that still needs to be burnt away. I cannot go to the next step with wax still in this material. That would be a disaster. I've got to have this completely burnt off and free of any combustible material before I go to the next step. I've got a little metal spatula here that I'm using to scrape the material off the bottom of the corningware dish. It's working pretty nice. It's been an hour and a half or so since I started this morning. Got the temperature at 466 Fahrenheit, 241 Celsius. What I'm doing here, it's pretty much all burnt up pretty good now. You can see it's not sticking no more. There's powder down here on the bottom, and that's about what we want to be at. But when I hit it with the flame, you'll see more smoke come off of here. If I can still get it to burn like that and produce smoke, that means the incineration is not done yet. So I'm going to have to keep doing this until I see no more smoke and no more flames coming from it. It's been about 2 hours and 30 minutes since I started this for the second day here. I've got the material at 389 Fahrenheit, 198.6 Celsius. And as you can see here, when I apply the flame, I don't get any more smoke. I don't get any more flames coming off the material here. And so this is telling me no smoke and no flames. There's a little bit of smoke there, just a touch. But this material is pretty much done here. So, what I'm going to do is turn this off now and just let it cool down, and we'll go to the next step in the process. The material has been allowed to cool down to room temperature. Now what we're going to do is a piece of cardboard here to catch anything that might spill out so I can sweep it up easily. I've got a mortar and pestle here. I've got a 2-liter beaker with a fine mesh screen in it. And what we're going to do is grind this material up and then run it through this screen here and pick out any foreign material that I might have in there. You can see where having all the wax burn out of here is important for this step. If I still had wax in here, it would tend to gum up the process here of grinding these pieces up. And then once I get them ground up, I'll run them through this fine mesh sieve here. Should be like a powder, what we're looking for here, to get it just finely divided state as possible. If it don't make it through the screen, then we pour it back into the mortar and pestle and grind it some more until it will go back through that screen. I'll do the entire batch just like this. This is the last little bit. I'm going to sweep this down into the container here and grind this last little bit up, and then we'll be done with this phase. Sweep up all this stuff that we spilled here. Little piece of buffing wheel hub there, made out of brass, and we'll get that out of there. Grind the rest of these little few granules up. Get it through the sieve and we'll be done. This took about a half an hour to complete this. Here's what was left in that fine mesh screen. Looks like one little bitty diamond right there. The rest of these I think are pieces of solder and other waste material. We'll give the diamond back to the jeweler. Okay, here is our finely divided bobbing compound. It's been incinerated, it's been chopped up into a powder, and we run it through the screen, fine mesh screen there. Now what I'm going to do is hit it with a little bit of dilute nitric acid, see if we can get any silver out of it. I just spoke to the jeweler. He says he doesn't do much silver. It should be all mostly gold and just traces of platinum. So we're going to hit with some dilute nitric acid now. Here's our bobbing compound. It's been incinerated, formed into a powder. I'm going to put it up here on my hot plate stirrer. Add a stir bar. I don't know how well the stir bar is going to work here because it's going to turn into like mud here. I'm going to turn the stir bar on, put on some heat, and now what I'll do is add some distilled water to it. The jeweler says there's not much silver in here, but it don't take much silver to gum up the works. So I'm going to put some distilled water in there, and then I'm going to add some nitric acid, and we're going to try to dissolve out any silver that we can before we put this in Aqua regia. I'm going to stir this up a little bit, get everything wet down in there. The reason I'm doing this is to get the silver out of here. If any, there'll probably be a little bit of silver in it. And so I want to dissolve all the silver out that I can before I put this in Aqua regia. Because if I go straight to Aqua regia with it, the hydrochloric acid in the Aqua regia will react with any silver in here, forming silver chloride, and create a problem in the next step. So I'm going to try to get all the silver out of here before we go to the Aqua regia. We'll let this boil for a little while. It's been on the heat for about an hour now. Getting a lot more fume production. Temperature's up to 164 Fahrenheit, 73.2 Celsius. Just going to keep this on the heat, let it boil until all those fumes go away. The material has been boiling in nitric acid now for about 3 hours. I'm turning off the heat and the stir. I'll pull this down off the heat now and let it cool off. And then we'll filter the material out of that nitric solution and go to the next step. I'm going to filter the solids out of our cooled off liquid up here, and to do that what I'm going to do is make a special filter. This is a 12.5 centimeter Buckner funnel, and this one here fits down into it pretty good. So what I'm going to do is use this funnel, center it up on a piece of this 24 centimeter filter paper, and then just fold the ends up like this and make a custom fit filter that will fit down in here. And what this will do for me is prevent any of the solid material from bypassing the filter and getting down inside the funnel. Alright, now we should be able to take and slip this right down inside of our funnel here. And what this will do is this will capture all of my solid material, and none of it will be able to get inside that funnel there. I've got the vacuum pump running, got my specially prepared filter here. This is a rubber seal that goes on the flask. And now what we'll do is get the filter paper to seal up with some distilled water. See if I can get this adjusted for you. we want this thing to seal up real good. So I'm going to hit it with some distilled water and push it down around all the holes in the bottom of the Buckner funnel. And we do have a vacuum showing up over there. The solution's been cooled down to 36.6 Celsius, 98 degrees Fahrenheit. What we're going to do is pour it through this filter now and collect our solids in the filter and collect the solution down in this flask down below. I've got all the liquid pulled out of the solids now, for the most part. It took about 45 minutes to pull it all through. Now what I'm going to do is rinse the solids with a little bit of distilled water here. We should have all of the silver out of here now. And then once we get this rinse water pulled through the solids, I'll get this in some hot Aqua regia, and we'll extract the gold from it. All the rinse water's been pulled through here now. I'm going to disconnect this, set it off to the back here, and what we'll do is I've got a big 4-liter beaker here, and I'm going to use this as our reaction vessel to dissolve the gold out of this material here. See if I can get this out of here. Bang. And there you go. You can see the funnel stays nice and clean with that custom-made filter paper. I'm going to set this out of the way. We'll do some tests on this solution and see what we got in there. But for right now, what I want to do is get set up to start dissolving the gold out of this out of these solids here. So we're going to put a Corningware dish down, put our beaker on here, and I've got some hydrochloric acid. I'm going to add some hydrochloric acid to the beaker there, and then we'll add small amounts of nitric acid to it. Put the stir bar back in, and then we'll add small amounts of nitric acid to this to form Aqua regia in there, and dissolve the gold out of this material here. Cover it up. Turn the heat on, stir bar, and just let this cook now for a little bit, heat up. Alright, everything is still cold. I've got some nitric acid here, and what I'm going to do is add just a touch to it just to get things going here. Maybe about 20 or 30 milliliters. And then we'll just let this heat up and start dissolving out the gold. The gold is beginning to dissolve here. I can tell by the fumes present. We've got hydrochloric acid in here and about 25 milliliters of concentrated nitric. While we're waiting for this, what I'm going to do is do a couple of tests here on our green solution that we filtered off of the solids. I'm going to add a little bit to this small container here. Now what I'll do is I've got some little pieces of filter paper cut up here. Grab one of these. And I've got some stannous chloride. I just made this fresh today. And I'm going to check and see if we got any gold or platinum group metals here in our solution with stannous chloride. And I don't see any reaction at all. So I don't think we have any platinum group metals or gold in our green solution. Now I'm going to add a little bit of hydrochloric acid to this solution. See if we got any silver in here. If there's silver in here, as soon as I put this hydrochloric acid in, we'll get a cloud of silver chloride forming. There it is. You can see that cloud of silver chloride forming in our solution. It's not much, but I'm glad we did that treatment to get this silver chloride out of our solution before we went to the Aqua regia, because a whole bunch of silver chloride up here in this reaction vessel would create problems when we go to filter. There's probably less than an ounce of silver in this solution, but it will have some excess nitric acid from that treatment that we did on the solids. So what I'll do is I'll pour this into a beaker, add more silver to consume any free nitric that's still in here, and then once that reaction is complete, I'll add copper to the solution and cement all the silver out and recover it that way. This has been heating now for about half an hour. I'll reach in here and stir it up a little bit. If I remember correctly, when I added nitric acid in a previous video that I did of this stuff, it flared up pretty good on me. So what I'm going to do here, get the temperature right quick. We got it at 66.2 Celsius, 151.5 Fahrenheit. I'm going to measure out a little bit of nitric acid here and add a little bit more here, but I'm going to add it real slow. Let's see here, I'm going to add about 20 milliliters or so. Pour this in real slow now. So I got a feeling it's going to kind of want to fizz up on me. Okay, here it comes. Looks like it's moving a little bit. I got the stir bar running in there, so it's self-stirring. I'm going to add a little bit more of this nitric in here now. See if I can get this in here and let it cook for a while. Watch out adding that nitric, man. It could take off on you at any moment. I've got a piece of filtered paper on the end of a bamboo skewer here. I'm going to reach down in there and get a little bit of the solution on this filtered paper. And then I'm going to test it with some of my freshly made stannous chloride. See what kind of reaction we get here. Oh yeah, it's turning a dark, almost black stain. So we definitely got gold going into the solution here. It's been on boiling now for about an hour and a half, boiling and stirring. I've measured out some more concentrated nitric acid in this container. I've got some gloves on here, If I add this and this takes off on me, I'm going to take it, move it over here to this big container so that if it overflows, I'll be able to recover all the liquid that overflows. So here we go, a little bit more concentrated nitric acid going into the reaction vessel here. Let's see what that does. So far it's been pretty docile. Now notice the amount of fumes being produced has slacked off, so we might have everything in solution. Go ahead and pour the rest of this in. That'll be a total of 75 milliliters of concentrated nitric acid in the beaker with the material. Been boiling in this hot Aqua regia now for about 2 hours. I'm going to turn the heat off, let this cool down a little bit, and then I'm going to transfer it into this tall beaker. It'll settle overnight, and then I can draw off the pregnant solution so we can precipitate the pure gold in the morning. I've allowed this to cool off a little bit here. What we're going to do now is transfer the solution. Still kind of hot, but I added some distilled water to try to cool it off. Get my squirt bottle so I can start it here. Now what we're going to do is pour our gold-bearing solution into this tall beaker so we can get it to settle overnight. When we come out in the morning, we should have a nice clear solution that we can draw off and then precipitate out the pure gold. Here's our pregnant solution. The material's been allowed to settle overnight. And now what we're going to do is I've got a funnel set up down here. And what we'll do is siphon the material out of here, down into my funnel. Got a tube here, I'm going to fill it full of water. And I'm going to hold one thumb over this end to close it off. I'll stick this end inside the solution, siphon it down into my filter. I'm going to rearrange everything now and get this set up to get the rest of this material poured through that filter. Get these things out of the way here. Now what we'll do is get the rest of the material down in that filter and get all the gold-bearing solution out of it. This is going to take a while. It's coming down drips at a time, and I've got a lot of liquid to pull through there. So while I'm waiting, this is the solution from earlier in the video where we removed the silver with nitric acid treatments. It's got some free nitric in it, and so what I want to do is I want to use up the free nitric acid by putting some pieces of sterling silver in it to consume that excess acid. If I skip this and tried to put copper in here to cement the silver out, then it would just needlessly consume the copper. So I'm going to remove the excess free nitric acid by adding more silver before I try to cement the silver out on the copper. This is sterling silver. You can see written right down here, it has the word sterling written right on it. Same thing with these sterling silver spoons. The word sterling is written right on the back. Alright, as usual, we're going to go ahead and burn this first before we put it in our solution to burn off any combustible material. First step in any refining process is usually incineration. And I'm going to put it in the solution. I've got a small tray of sterling silver material here that I'm just going to go ahead and heat and add to both of these solutions back here to continue to consume the excess nitric that those solutions contain. Adding this silver to these solutions will ensure that all of the excess free nitric gets consumed. I can tell when it's done, when there's no longer any reaction, no fumes being produced, and there's a little bit of undissolved silver left in the bottom of the beaker. This will guarantee that I don't needlessly consume copper in the next step when I go to cement the silver out of those solutions with copper. This has been filtering now for about an hour, and I think I pretty much got just about all of the gold rinsed out of the solids here. I can tell when it's all rinsed out when the drips coming out of the bottom of that funnel down there start running clear. So we're just about done here, and we can take this solution off and precipitate out the pure gold. See the yellow solution coming out of the bottom of the funnel there? That tells me that we're still rinsing gold-bearing solution out of those solids up in the funnel. Most of the material has been filtered out of our solids now. What I want to do here is show you a little test. This is some standard testing solution of gold. And what I'm going to do is put a little bit on the end of the filter paper there. And then I'm going to get a little bit of the solution out of this funnel on another piece of paper. If I can get it. There we go. So this is from the funnel. This is from my standard testing solution, 1 liter or 1 gram per liter of gold. We'll put some stannous on both of these, and we'll see what kind of result we get here. As you can see, there's less than 1 gram per liter in the solution coming out of this funnel. I've got most of it down into the flask here. So what I'm going to do is I'm going to take the funnel off. Here's the test with stannous of the standard test solution that has 1 gram of gold dissolved in 1 liter of liquid, compared to the test of the solution coming out of the bottom of the funnel over here. We've got less than 1 gram per liter. We still got gold in there, but it's just tenths only. So what I'm going to do now is I'm going to take the filter off. I'm going to transfer the solution into a large beaker and precipitate the gold out of our solution now. going to save the solids here in case my yield is way off. And if I have to, what I can do is put these solids back into a beaker, hit it again with more Aqua regia, and extract the rest of the gold, which there's going to be less than 1/2 gram in here, tenths only. I'm going to transfer the solution into this clean beaker, and we're going to do a precipitation now and see if we can get some pure gold out of this solution that we've extracted. I'm going to add sodium metabisulfite to our solution and precipitate out the pure gold. Make sure we got all the gold precipitated. Do a Stannis test here. And as you can see by that test, looks like we got a slight tint of orange, which is an indication of a little bit of platinum group metals in solution left here. All the gold is settled out. All the gold has been precipitated. This is trace amounts only. It's not enough to try to recover and refine. What I'll do is I'll put this waste solution in my stock pot and recover that later. Now I'm going to pour off the waste solution into a temporary container here because my stock pot is full. This will just be a temporary storage for this waste. It's got a little bit of platinum group metals in it. No gold in it. All that's been precipitated. So I'm going to put it in this container, and then later on when I get some room in my stock pot, I'll add it to my stock pot. Alright, here's a look at the pure gold down in the bottom of the beaker. I'm going to use a little bit of hydrochloric acid here to rinse our gold. And then we'll pour that into the waste container as well. We dissolve the gold a second time here. Put a little bit of hydrochloric acid, maybe about 50, 100 milliliters, 50 or 100 milliliters. Turn the stir bar on, turn some heat on. I'm going to add some concentrated sulfuric acid to precipitate any lead that may be present. And then we're going to add a little bit of concentrated nitric acid here to form aqua regia in there and get all that gold to dissolve a second time. That's 3 milliliters right there. I'm adding another 3 milliliters of concentrated nitric here. Gold is completely dissolved now. I'm going to take it down off the heat. Took about 10 minutes to dissolve that. What I'm going to do now is prepare for the precipitation. I've got a separate clean beaker here. I'm going to put about 200 milliliters of still water here. That's about 250. And then we're going to add some plant food, copperas. Copperas is ferrous sulfate. And what I'm going to do is dissolve some ferrous sulfate here, and we'll use it to precipitate our pure gold for this repurification. Make a concentrated solution here, a saturated solution of ferrous sulfate. That should do it for the amount of gold we're talking. Now I'm going to add just a touch of hydrochloric acid to it so it turns green. See how it looks brown there? We add some hydrochloric acid until it turns green. Now we'll just let that dissolve, and then we'll use it to precipitate our gold. Adding some ice cubes to our gold here. Cool it off so we can filter it again. By the way, those ice cubes are made from tap water. That was one of the questions folks had from some previous videos. Let's get this stir bar out of here. We're going to filter the gold solution again. Flask back here has got some sediment in it. It's got a little bit of the gold solution in it, so what I'm going to do is pour it off into this glass cylinder, and then I'll let it settle and get that little bit of gold solution out of there. Pour this back through the same filter now. Try to get some of that cloudiness out of our solution. me get set up to filter the copperas into the gold solution here. Turn my vacuum off. Get the funnel out of the way here. And we'll set up and precipitate this gold a second time using the copperas. The solution's nice and clear, indicating that we've got some pure gold here. Here we go. We're going to pour the copperas through the filter now into our gold solution and precipitate out our pure gold. Copperas, or ferrous sulfate as it is known, is fantastic for doing repurifications. It brings down the gold, all the gold, and nothing but the gold. You'll notice at the bottom of the beaker, through this sequence that's speeded up 8 times normal speed, that the gold will begin to accumulate at the bottom of that beaker. Alright, let's do a status test here. Make sure we got all the gold out of solution. As you can tell by that test, if we had gold in there still, it'd be a dark brown stain. That yellow is from the copperas, the iron in there. So, what we're going to do now, move this funnel out of the way. And I'm going to take the waste solution, pour it into this temporary waste container, and get rid of the waste solution so we can get our gold out of here. Alright, here's our pure gold precipitated with copperas. I'm going to give the gold a quick rinse with some hydrochloric acid here. Get all that iron off of it. Squirt these pieces down off the edges here around the sides of the beaker. We'll pour this in our waste container. It's our pure gold powder. It looks pretty good. And some of that stuff down off the sides of the beaker there. I'm going to give this a couple more rinses with hydrochloric acid to get all the iron out of that. Pour this into the waste container. Hit it one more time with some hydrochloric. You can tell when the iron's gone here because the solution won't turn yellow like that when you pour the hydrochloric acid in. It's a good color indicator to tell us when we've got all the iron rinsed out of it. we go, one more time. I've got the gold up here on the hot plate. We're going to precipitate and dissolve and precipitate one more time here. Sulfuric acid going in to take care of any lead. And then we're going to add a little bit of concentrated nitric acid here. Concentrated nitric. It's about 6 milliliters. We'll just let this dissolve. Take it down off the heat now. Add some ice to cool it down. And then we'll precipitate it a third time. Alright, we're going to pour it through the filter. And then precipitate it for a third time. Get the solution in a clean beaker here and precipitate it for the third time. Nice and clear. This third precipitation will guarantee we got some very high purity gold here. Alrighty, let's get some SMB in there, sodium metabisulfite, and precipitate out the pure gold for a third time here. Be very pure when we get done with this process. In to do some video editing. I was in there for about 20 minutes, 25 minutes or so. Came back out. This stuff is settled. It's settled quickly and cleanly. If you look, that gold just looks absolutely gorgeous. You can tell that's going to be high purity, 24K 999 fine gold. I'm going to go ahead and pour off our waste solution here. Hydrochloric acid ready for the next step. And again, this is a temporary storage for my stock pot because my stock pot is full. So this waste that I'm pouring off here will go into my stock pot. Here we go. We're going to rinse off the gold now with a little bit of hydrochloric acid. Get all the chemicals rinsed out of there. Probably going to be a little bit of excess SMB. Get that all rinsed off. Get this gold looking really good. Just going to keep rinsing with hydrochloric acid until I get a clean, clear rinse. Small amounts is better than large amounts. Many rinses with small amounts is more beneficial than trying to rinse with a large amount. Nice, look at that gold, man, nice. Pretty looking powdered gold there, very nice. I've given it 5 rinses with hydrochloric acid until the acid was absolutely clear. And that was my 4th rinse with distilled water. And I'm going to do one more rinse for a total of 5 with distilled water. Gold looks absolutely gorgeous. 5 rinses with distilled water. And here's what the gold powder looks like. Very nice. Got a clean melt dish here. See if we can get our powdered gold down into the melt dish. Easy enough. Now what we'll do is use a little pipette here to get all the water out of there. And then we'll take it over on the melt table, melt it up into a nice bar. Alright, we're going to take this over, put it on the melt table, and fire up a torch here. Start melting our pure gold into a nice little bar here. Oh yeah, this is a beauty. This one came out really good. No traces of contamination on the surface. That's very high purity gold there. Let's get a weight on this thing and see what kind of yield we got. Got 18 grams. 18 grams of 999 fine gold. Absolutely beautiful. First we got 3 tips. Came out good. 999. Let's see, I'm going to cock this just a touch to the left. Got the word fine here. Nice. And the word gold. One, then I need the 8. And then the G, and then we're done. Here's the finished bar. 999 fine gold. 18 grams. And then 3 tips. This was a nice one. I'm going to put this on my eBay store and let this one go on my eBay store. This will conclude the video. This took all week. I started on Monday morning early, and this is Thursday evening about 7:30. So it took 4 days of continuous work to get this pure gold ingot here. This is only the second time that I've processed this type of material, this jeweler's bobbing compound. I'm kind of glad it's over. But what we'll be doing, we got the pure gold ingot here, and I've got my my name stamped on it. I've got the weight, 999 fine gold. It's been triple refined, and what we'll do is we'll list this on my eBay store. My eBay store name has changed from Baffalus to 3 tips to match my YouTube user channel. Alrighty. Let's see what we got here. We got a yield calculation. What we did was we started out with 456 grams of the bobbing compound. We got 18 grams of pure gold from it. Plus there's probably maybe another half a gram out there in the residue that I saved. So based on the result of this ingot, our yield was 3.9% for this jeweler's bobbing compound. Okay, I guess that'll conclude the video. Thanks for watching.